All right, guys, we're going to do more quadratic modeling. All right, this lesson's more of comparing functions than modeling, but it kind of falls into that category. All right, so if you look at question 1, it says, which quadratic function has the largest maximum? All right, when they talk about the largest maximum or the minimum or the lowest minimum, they're looking at the vertex. All right, now, sometimes they're going to give you the equation like choice 1. Sometimes they're going to give you the table of values like choice 2. And sometimes they're going to give you the graph like choice 4. On this example, 2 times they gave an equation. All right, these are all different functions, and we're trying to compare them. I would look at the ones where the table or the graph is given first. So if I look at the table, choice 2, you see it goes -3, 5, 9, 9, 5, -3. So your vertex is in here. Keep in mind, it's a little higher than 9. So let's say it's like 1.5, 9.5, right? Because there has to be something in the middle. If you look at the one where they gave you the graph, this is our vertex. And this looks like it's 1, 2, this is 2.5, 1, 2, 3, 4, let's say 4.5. So clearly, so far, the table is the largest. All right, the other ones we're going to have to plug it in the calculator to graph it. So number 1, I plug in 3 minus x, 2 plus x. Okay, remember, when they say h of x, that's really y. And then I plug in the equation exactly the way they show it. First, you want to look at the graph, get a feel for what it looks like. All right, you can see that the turning point is just to the right of 0. So I go to my table. All right, you may need to scroll up and down, but you should see that the turning point's in here. Right, it goes 0, 4, 6, back to 6, back to 4. And again, it's really not at 6, right? It's really going to go a little higher than 6. But if we said it was 1, 6, or let's say it was 6.5, that would be close enough. So right now, you can see that the one with the 9 so far is the highest. All right? Then I'm going to plug in choice 3, which is that other equation, k of x. Right? Negative 5x to the second minus 12x plus 4. All right? And we're going to graph it. Now, if you look at this one, keep in mind that this is a 10 by 10 grid. So this one went above 10. So clearly this one is higher than 10. But if I want to get a better feel for that, I'm going to go to my table, which I got to go values less than 0, right? Because it's to the left. So I'm going to scroll back, right? And if you see, it may be a little trickier to see, but see how these values are low? You get to 8, you get to 11, and then they start going back down. So we're going to say it's -1, 11, but it's probably actually a little bit higher. So if you look at it, this one's going to have the greatest maximum, choice 3, the one with the equation. All right? All right, let's take a look at number 3. This question says, which statement is true about the quadratic functions g of x, which if you look is the one with the table, and shown in the table below, and f of x, which they're giving us the equation. So, what we're going to need to do is plug in f of x, all right, which is parentheses x minus 3 to the second plus 2. All right? I'm going to go to the graph, but really we're going to need to look at the table. All right, so this is the graph. All right? I start looking through the choices. I got to go one by one. Choice 1 says they have the same vertex. If you look at the table, see how the values, they go 4, -1, -4, -5, back to -4. This is our vertex. If you look at the graph in the other function, all right, it looks like it's going to be different, but I'm going to pull it up. Ready? It's to the right of 0. And if you look, it goes 6, 3, 2, back to 3, back to 6. So 3, 2 is our vertex. So I'm going to write down for f of x, our vertex is 3, 2. All right, so they have the same vertex. That's false, right? They have the same zeros. Well, if you look at the table, the zeros are when the y value is 0, and they didn't tell us that. And if I go to the graph of the other one, it never touches the x-axis. So there are no zeros for that one. So number 2, that can't be right. All right? Number 3, they have the same axis of symmetry. Remember, the axis of symmetry is the x value in the turning point. So this one is x equals 3, and this one is x equals 3. So that's the answer. They have the same axis of symmetry. All right? All right, question number 4. All right, and then I'm going to have you guys try some on your own. It says the graph representing a function shown below. So this is one function, the graph. The question asks, which function has a minimum that is less than the one shown in the graph? So again, they're talking about minimum, so they're talking about vertex. So what I'm going to do is I'm going to graph each one of these functions, find the vertex. All right, the one on the graph, I'm going to pull off the graph. So if I look, this is over 1, 2, 3. And it's down 1, 2, 3, 4, 5, 6, 7. So I'm trying to find out which one of these has a vertex that has a y value lower than -7. Right? Because they want a minimum that is less than that. All right, one by one, we're going to graph these equations. All right, so I'm going to do the first choice. Y equals x squared minus 6x plus 7. I'm going to graph it. All right. If you look at the graph, it's obvious. Look, this is a 10 by 10 grid. All right, it's not going anywhere near -7. But if you wanted to look at the table to be sure, again, our vertex is to the right of 0. So I'm going to want positive values. And if you looking at the values, see the vertex is 3, -2. So I'm going to write it next to it. But this one's out, right? It's got to be lower than that. All right, I'm going to try choice 2, which is absolute value. Go back to y equals, clear it out. Remember, to get absolute value, you hit in y equals, you hit math. You hit the right arrow over the number. Hit enter. All right, type in x plus 3. But keep in mind, the -6 is outside. So you got to hit the right arrow to get out. Graph it. Now, this one's going to be close. But if you see, it's going to be higher than -7. It's to the left of 0. I'm going to go to my table. I got to start going back. All right, if you look at the values, you see that -3, -6 is the turning point because it repeats on both sides of that. All right? So -3, -6. And again, it's this number I'm looking at. All right? -6 is not lower than -7. That's not the answer. All right, I'm going to try choice 3. Plug in x squared minus 2x minus 10. Graph it. Now look at that one. This one goes all the way down and it gets cut off, which means the vertex is below -10. So this is going to be the one. I'm going to go to my table just to be sure. Keep in mind it's to the right of 0, so I need mostly positive values. And if you look at it, there it is. It goes -2, -7, -10, -11, back to -10. So this one -11, this is our vertex. This one's lower than -7. This is the answer. All right, so I'm going to have you guys try some more on your own. All right, and post the answers. Have a good one.